Hey everybody, I'm going to give you a mini lesson on chapter 4.8, Isosceles and Equilateral Triangles. This will close out chapter 4 for all the stuff that we'll be doing for remote learning. And then at the end of this chapter, we're actually going to do a project. So I'm going to assign that on Tuesday. But we had to finish up chapter 4 before I could do that. So here is chapter 4.8, Isosceles and Equilateral Triangles. What is an isosceles triangle? An isosceles triangle is a triangle that has at least two congruent sides. So if an isosceles triangle has exactly two congruent sides, then it would look like this picture here. Now you'll see what I did here. I didn't stand this triangle straight up so that the vertex angle is at the top. And I did that for a reason, because I want you to understand that the vertex angle of an isosceles triangle is not always at the top of the triangle. Sometimes it's over here on the side or on the other side. So how do you know where the vertex angle of an isosceles triangle is? Well, you've got the two congruent sides. Those are called legs. So the angle that's formed by the two legs is the vertex angle. Now the other side of an isosceles triangle is called the base. So you've got your two congruent sides, which are called legs, and then you've got the other side, which is not congruent to those, that's called the base. The two other angles of a triangle that's isosceles, that is not formed by the congruent sides, those are called the base angles. And the base angles of an isosceles triangle are congruent. So across from each leg is the base angle. So two congruent sides, two congruent angles. You can find all this information in your online textbook as well in case you want to see it there in front of you. So those are the parts of an isosceles triangle. Now, moving on over here to an equilateral triangle. An equilateral triangle is also isosceles because it does have two congruent sides. However, an equilateral triangle, equilateral means all equal sides. So an equilateral triangle has all sides equal and all equal angles. And since all of those equal angles have to add up to 180, then we do 180 divided by 3. So each of these angles has to be 60 degrees. So every equilateral triangle, even if the side lengths are different, will always have 60-degree angles. All right, other things to remember for this worksheet that we're going to be doing is that you still have to know that vertical angles are congruent to each other. That comes up in this worksheet as well, so you have to make sure you remember that. You also have to know that all of the interior angles of a triangle add up to 180 degrees. So triangle, 3 angles, and they all have to add up to 180. You have to remember that a straight line or a straight angle adds up to 180 degrees or is 180 degrees. So if there were 3 angles that made a straight line, they would all have to add up to 180. And then last but not least, the acute angles of a right triangle are complementary. It's actually the same thing as this interior angles one, because 90 plus the other 2 angles would still add up to 180. But going back to this one over here, this is a corollary to that theorem, and it was in that chapter 4.1. Acute angles of a right triangle are complementary. So what kind of problems are there going to be on the worksheet that you have? Here are some examples. So first of all, when you have an isosceles triangle, they do not have to give you more than one angle. They only have to give you one angle. Your job is to figure out what kind of angle is it. Is it the vertex angle or is it a base angle? So if I look at this first example here, this is a leg and this is a leg, which makes this the base, which makes this a base angle, which is congruent to the other base angle. And this up here is the vertex angle because it's formed by the 2 legs. So how do I find out what x is? Well, if that's 70, then that is 70. 70 plus 70 is 140. So this vertex angle has to be 180 degrees minus 140 to find out what's left. And this would be 40 degrees. Okay, so like I said, once again, going back to our other to our other things that we needed to know. We needed to know what is an isosceles triangle and what do all the angles in a triangle have to add up to. That's how we did this problem right here. Okay? Now, how does that one different from this one over here? Well, they turn the triangle a little bit, so I still have to identify what are the legs, the congruent sides. This is the vertex angle then. And that would make this down here the base. And these are the base angles across from the congruent sides. So if the vertex angle is 50, that means that there are two angles left. And when I subtract 50 from 180, those two angles have to add up to 130 degrees. And since they're congruent, this is also x. So x plus x, or 2x, has to equal 130. For those people who are already way ahead of me, you probably just said, just take that and divide it by 2. Okay, and if you do that, you would be correct. You get 65 degrees. All right. Now I have another example problem over here where we're solving for x, and we have an isosceles triangle. Now, there's a little bit of a distractor in this problem. I did it on purpose because I don't want you to confuse the sides of a triangle with the angles of a triangle. All of the angles inside of a triangle add up to 180. These are not angles. They are giving you sides. How do I know they're sides and not angles? Well, first of all, they put them right here in the middle of the side. And the other thing is they're outside of the triangle, not inside of the triangle. So they're giving you sides. So this 6x actually is not going to be part of the problem at all because this is the leg of the isosceles triangle and that is the leg. So therefore I know these two things have to be equal to each other. So 3x minus 10 has to be equal to 5x minus 30. That's the equation I have to set up to solve for x. Now, how do I do that? I start with the smaller variable. We've done this type of problem before. Do the opposite of that on both sides. And then I like to use the seesaw method. I brought the variable this way, so I'm going to bring the number over that way. So I'm going to do the opposite of minus 30, which is plus 30. I am not combining like terms because they're not on the same side of the equation. So I end up with 20 is equal to 2x. Divide by 2, x equals 10. Should you check your work to make sure that it's correct? Absolutely. 3 times 10 is 30. 30 minus 10 is 20. So this side is 20. And over here, 5 times 10 minus 30. 50 minus 30 is also 20. Bonus question, let's say I did want to use this 6x and I wanted to know what the perimeter of this triangle is. Perimeter means add up all the sides. So 20 plus 6 times 10, which is 60. 60, 20, and 20 all add up to 100. So they could have asked that problem instead. All right, 2 more examples. Over here, here's another isosceles triangle problem. But instead of like the first 2 examples we did, instead of asking for just what x is down here, they have an expression 4x plus 15. So how do I go about solving that? Identify the legs. Identify the base. That means these 2 angles down here have to be congruent to each other. And how is that going to help me? Well, if I know the vertex angle is 70, 180 minus 70 is 110 degrees. 110 degrees, and there's 2 angles that have to add up to 110. So what should I do with that? 110 divided by 2 is 55. So each of these angles have to be 55. Now, how do I use that information to solve for x? Well, if I know this angle is 4x plus 15 and it's supposed to equal 55, I just set up an equation. 4x plus 15 equals 55. And then we just solved that two-step equation. Subtract 15 from both sides. I get 4x is equal to 40. Divide by 4, x equals 10. How do you know if your answer is correct? Put that 10 back in here for x. 4 times 10 is 40, plus 15 is 55. Congruent to the other 55, 55 plus 55 plus 70 all adds up to 180. And now we have one last problem. This problem here, they give you two angles. They tell you the perimeter of this triangle is 72 units. So if these two angles are 60, this angle here also has to be 60. Why is that? Well, they all have to add up to 180. 60 plus 60 is 120. 180 take away 120 gives you 60 for the other angle. So 60, 60, and 60 makes this triangle equilateral. Because if all of the angles are equal, all of the sides have to be equal. So if that's 6x, then that is 6x, and this one over here is 6x. Perimeter means add up all the sides. 6x plus 6x plus 6x is equal to 72. That would be 18x is equal to 72. And divide by 18 to find out that x equals 4. If x equals 4, then this side over here is going to be 6 times 4, which is 24. And since all the sides are equal, 24, 24, and 24 adds up to 72. So that should take care of all of the types of problems you would see on the worksheet. Do your best. Make sure you look at the notes. And also you can look at the study guide in your online book. And as always, feel free to message me any questions that you have. Good job to all those people who have been messaging me questions. And I hope everybody is well, and try your best, and hopefully I'll see you soon.